Welcome to Chapter 6. In the first part of Chapter 6, we're going to talk about how do we solve a differential equation. And that's just fancy language for a differential equation is a derivative of an equation. So we're talking about these equations that start with dy dx. So for example 1, here are some key phrases to be watching for. It says to find all functions. What does that imply? Well, that should imply that we have more than one answer. And it says we're going to find all functions y that satisfy this equation. So here they've given us the derivative. So we've got dy dx equals secant squared x plus 2x plus 5. So here's the cool thing. We can separate these differentials, if you remember that back from chapter 4. I can move this dx over. And so now it looks a lot like what we were seeing in chapter 5 with these integrals. So that's exactly what we're going to do is we're going to integrate both sides. Now over here all I have is 1 dy. So the antiderivative of 1 with respect to y is just y. Now the antiderivative of secant squared, that's one of our flashcards. So that one was tangent of x. The antiderivative of 2x, our trick says to raise the power up 1 and then divide by the power. So it would be 2x squared divided by 2, or just x squared. And the antiderivative of 5 is 5x. But that's just one solution. What we need to remember here is I want all solutions. So I have to add this constant out here, because if I take the derivative of this, I still get this. So no matter what constant I put out here, this is still going to be my derivative. So I have to put this plus c. Now I have infinitely many solutions, and I have found all solutions y. So the difference is when we get to example 2, notice the phrase at the beginning says, find the particular solution. That implies one solution. And if I'm going to have one solution, it means I can't have this plus c. I'm going to have to figure out what that constant is. And in order to do that, and I can see it right here, they have to give me an initial condition. And so here it says the particular solution to e to the x minus 6x squared that goes through the point 1, 0. So again, I've got this equation. I'm going to move that dx over. And integrate. So the antiderivative of 1 with respect to y is y. The antiderivative of e to the x is e to the x. The antiderivative of negative 6x squared, I have to bring the power up and divide by the power. So 6x cubed divided by 3. So minus 2x cubed plus a constant. Now I need to use my initial condition at 1, 0. So this is my x, this is my y. So when I plug this in, I'm just going to leave this in this simplified version, so e and minus 2. So I'm going to move those over, so I get minus e plus 2 equals c. So my equation here ends up being y equals e to the x minus 2x cubed, and then my constant is minus e plus 2. There's my equation that goes through the point 1, 0. I'd like you to try example 3. Check your work. So on this one, I separated out my variables. And we get x squared minus tangent of x plus c. We plug in the 0.03 and we get y equals x squared minus tangent of x plus 3. All right, number 4. Still a dy dx type of an equation, but this one we don't know how to do the antiderivative of, and in fact we don't actually ever learn that one. So for this one, what I want to show you is another way that you can see these written. So we've got dy dx equals e to the negative x squared. We move that dx over. So we get y equals, when we integrate this one, the integral of e to the negative x squared dx. And what we can put in here now is that our initial condition started at the ordered pair 7, 3. And that means if it started at some point x, or 7, then we have to use some other variable up here. We would then say our y value was 3. So we've got this initial condition right here, and you can leave it just like that, and that's totally sufficient. Last but not least, they give us this equation here, dy dx equals cosine of x, and they want us to graph the family of functions. Again, that implies multiple answers. So if we were to, I'm going to just go ahead and separate that dx right away. The antiderivative of dy is just y. Antiderivative of cosine is sine plus c. So my favorite graph of sine of x plus c is sine of x plus 0, which would start here. And I'm going to just pretend this is 2 pi. So here would be pi. And I'm going to say this is 1. So, and then negative 1. So we'll say negative pi is over here and negative 2 pi. Ish. All right, so there's sine of x plus 0. And so since it says to graph the family of functions, you can now move it up 1 and graph the same function. And so basically they just want you to do multiple versions. And I could do one down here, etc. So you do as many as you would like, but it needs to be a family, so I'm saying 3 is a family. But you could, if you actually wanted to graph all of them, just color in the entire graph, but that will not fly on the AP exam, so don't.